Hi, my name's Eliot Smith. I work for Pro-Moto and we specialise in electric vehicle technology training. Today I thought we'd talk about troubleshooting batteries and the little hiccups and hurdles and curveballs that might come your way trying to troubleshoot, diagnose and repair batteries. One of the things is battery orientation. So as we know, there are a lot of cells inside a battery. They can be in series or in parallel, but as we know, diagnosing a battery, if we see a fault within it, maybe some imbalance in the battery, we need to understand what it is, where it is, and how we locate it. Okay, so here we give you an example. This is a very common vehicle, of course a Toyota, but it's a good example of how we can get orientation wrong against what data tells us and against what the orientation of the battery is concerned. And I want to give you an example of a Nissan Leaf, because then that gives you a little bit of a curveball, because you might make some assumptions about the orientation of the cells throughout the battery. Okay, so here we go. So here's an example of some imbalance in the battery. We've located or identified from our data list modules 1 and modules 3 within the battery. I'll just highlight those for you so you can see. Now, for anybody that's done some electric vehicle training and understands a little bit about battery technology, you'll understand that battery imbalance is quite a significant problem for batteries. And in most cases, if the battery imbalance becomes significant enough, it can mean the battery will switch off. Hence, we have a non-start situation. And as you can see from this example, there is quite wildly differentials between module 1 and module 3 as far as voltage is concerned. And clearly, this would give us a problem within the battery. So that's step 1. So it tells us we've got some imbalance in the battery and it's pointing towards a couple of modules within that battery. Okay, let's take it one step further. If we go into the data list a bit further, whilst it tells us 1 and 3, now the voltages aren't so significantly different. But at some point during that battery analysis, when load was put on the battery, then there was significant. As we know, load or current through the battery produces more imbalance in the battery as far as the data list is concerned. But when we delve into a bit further with diagnostics, we come up against a little bit of problem. Here's our live data list. So we're now looking at modules 1 to 6 to see if we've got any other significant imbalance in the battery. And we're probably going to focus on 1 and 3 because that's what it tells us as far as the diagnostics is concerned. But if you look now, it's now telling us it's 2 and 4. So this is like kind of a bit of a curveball for us. So is it 1 and 3 or is it 2 and 4? Because obviously we want to identify it before we start pulling the battery down. We want to make sure we're looking or focusing on the right parts of the battery as far as that's concerned. Okay. So, a bit of a question mark for us here. Okay. The answer to the curveball is that there's a little quirky bit in the software. When you look at the data list, okay, modules are numbered 1 to 4. Okay. So in this case, actually, we're looking at 2 and 4 as the probable fault within the battery. When we look at the min-max numbers, they are numbered 0 to 13. So whilst we're getting the correct data, the software has been configured slightly differently to give us a little bit of incorrect reading. Okay, so that's the first problem as far as the battery is concerned. So we start to have to sort of say, well, okay, how can we make sure we're looking at the right cells? So now we're going to have to look at actual measuring voltages within the battery to see where that problem is and does it correlate to what we suspect the problem is within the battery. Okay, the other problem is well, where is number 1 and where is number 14? Because as we know, there's a positive and negative in the battery. So if we look at the wiring diagram for this example, we look at, say, the positive side of the battery. Here's our numbered modules throughout the battery. They're labeled 1 to 14. Now you'll notice there's an additional connection. That's the negative terminal of the battery. Okay. All right. So there's 15 connections, but there are 14 voltage readings within the battery. Okay. So if we look at the positive or negative side of the battery, this actually connects to module number 1. So we can assume then that module number 1 is on the negative end of the battery. Okay, and if we look at the positive side of the battery, it actually connected to number 14 within the battery. So that's reasonably easy to understand. And logic would tell us that's how the orientation of the battery is. Negative starts at the lower number, the positive finishes at the higher number. Okay, so when we go into the battery, then we can use our data list, our live data, and then we can measure the voltages across the battery to confirm which one we suspect is the rogue module. And then we can carry out a possible repair on that. Because at this stage we've got it wrong. We would say if we didn't identify it manually with the voltage readings, we can actually end up repairing the battery inappropriately or changing the wrong module, and we're back to square one again. Okay, so that's a Toyota or Lexus orientation and troubleshooting a battery. Okay, so as you can see, this will be 2 and 4 is the biggest variance in the battery. Let's look at a Nissan Leaf then orientation. Now we would say, okay, if we got the same problem, maybe the negative end is where the modules start and the positive end is where the modules finish as far as numbering is concerned. So let's say we've got module 22, for example, this has 48 modules within the battery. So they're 2 cells per battery, that gives us 96 cells in the battery. So we identify, say, module 48 or 22 or whatever it is as the faulty module containing the faulty cell within it, because it's got either a breach of insulation or it's got imbalance or whatever it is. If you look closely, this is the layout of from the workshop manual. Here's the negative terminal, and it's pointing to the junction board, okay, connected to module 48. So the negative end is the higher number. To confirm that, if we look at the positive side, okay, it's saying it's the positive terminal, which is at module number 1. So again, if we're looking at a particular module we want to focus on, make sure you're locating it from the right direction within the battery. Otherwise, you get a completely wrong diagnosis and repair of the battery. It's a little curveball for you to understand. Okay. So in this case, the highest potential is module number 1, and the lowest potential is module number 48. So just make sure you understand the orientation of the battery, you understand and you diagnose and troubleshoot what the fault is in the battery, and then you hopefully, if you're equipped and skilled enough, you can repair the battery or get someone else to repair the battery for you. Okay, so that's a fairly simple little nugget of information. So points to bear in mind to review this: compare the various sources of data, fault code, info, data list, whatever it is, whatever you can find out, have a good look in your diagnostic equipment to look at different references to identify the problem with the battery. Compare that data with some manual measurements. So once you're inside the battery, make sure you understand that you've identified the fault. It may be a poor connection. It may not be the battery itself. We've seen corrosion build-up within the battery that can produce incorrect voltage readings to the control unit. So therefore, we can actually have quite a reasonably easy repair rather than having to change a battery or a module or a cell within the battery pack. Use reliable sources of information. Always important, as you know. Manufacturer's technical information, wiring diagrams will always help you to understand where the problem is. And finally, understand the orientation of those modules and cells so you can then locate that section that you want to troubleshoot. Okay, guys? So little simple things that you can pick up on and easy to make sure that you don't make mistakes. Okay, that finishes off what I wanted to talk about as far as battery orientation is concerned. Listen, guys, if you want to get skilled, if you want to get some training, come to us, give us a shout. We do level 3s and level 4s, and also we have a specific battery analysis, diagnosis and repair course. To do that, we ideally want you to complete both level 3s and 4s, so you're competent to work on live voltage systems. Give us a ring, talk to the office, go online, you'll easily find some information out of that. If you're not sure, as I say, give us a ring and we're happy to talk to you about the information available and the bookings available for you. Go to our website, www.pro-moto.co.uk, phone us 01252 377762, or you can email us at enquiries@pro-moto.co.uk. Okay. Alternatively, if you pause this video, scan the QR code and it'll take you directly to our website. Okay, guys, thank you for listening. See you soon for the next episode of our little nuggets of information as far as electric vehicle technology is concerned. See you soon, guys. Bye-bye.